Hey guys, so we're just gonna continue with what we were doing, which is bonding. So we have the electron dot formula PowerPoint. It's a PowerPoint you'll get for your notes. It's basically the video from Google Classroom, but in the PowerPoint form. For some reason, it's called electron dot formulas, but really it's bonding. Then we're gonna do these bonding notes, which we basically take the most important information from the PowerPoint. And then we took a quick quiz where I just asked the students in their own words, what is covalent bonding and what is ionic bonding, okay? And we're preparing for a quiz. Okay, what I want y'all to do is to go on to Google Classroom, and we did not get to the second video. We got to this first video. But we did not get to the second one. So what I want you to do is to watch this first one. It is 10 minutes long, but it's basically what we're doing here, okay? The second one is more specifically what's going on with ionic bonding, and you're more than welcome to watch that too. Then at the bottom, we have the 2 PowerPoint slides from the 2 hyperlinked videos. This is the one that's in your notes called electron dot formula PowerPoint. So you got this one. This one we haven't got yet. Okay, then I have 4 images of my board. These are all the notes on my board. And then this last one is the worksheet that we're doing together. Okay, so if you can't read it, you could just open any of these. So you will be expected tomorrow to have, the video watched and to have all of this filled out. Okay. Let me just set up my camera. No. I'm not prepared for this. Okay, we're gonna do this right here first, bonding. Okay. Okay, you'll get this from your teacher, me, or your sub, and so this is where we're gonna fill out together. This goes over that whole video. I do want you guys, before you start this, to watch that 10-minute video. This will make more sense. Okay, so we're doing this right now. Okay, first thing we're gonna go over is what's the difference between covalent bonding and ionic bonding. So elements are usually by themselves: hydrogen, oxygen, chlorine. Sometimes they're bonded together, H2. Sometimes they're bonded to another element, H2O. Okay, so when we see elements and they're in a chemical formula, C6H12O6, they're bonded together. Now, by looking at them, normally you can't tell if they're covalently bonded or ionically bonded. Usually it's covalent, but now we're gonna be able to figure out how to tell if it's covalent or ionic bonded. So what is the definitions? Let's do covalent first at the top. So this is not a definition, co-share, but I do want you to look at the prefix co-captains, camaraderie. Co means together, so you do it together, you share. So when it comes to when the electrons are in their valence shells and then they make that bond between hydrogen-oxygen or hydrogen-hydrogen, are they sharing to fill their valence electrons shells, or are they stealing? So co meaning share, and then E negative is our new symbol for electron. So I don't ever have to write out the word electron, I'll just do this. But the definition that I expect on your quiz, covalent bond, it's a bond between 2 atoms. And we're not saying it's between 2 elements, it's because we're talking about the smallest form of an element, which is an atom, who share electrons. And our example is water. So go ahead and write that down now. Oh, my bad. Sorry if you couldn't see that before. Okay, so our example is water. Now, what you're going to do is you're going to look at your periodic table, so up on the board, and I'm going to go to H2O. So there's two hydrogen atoms and one oxygen atom, so there's a total of 3 atoms, okay? We'll put oxygen in the middle, okay? Going up to my periodic table. Am I in the shot for this?
No.
What about now, if I do it right here?
Yeah, you're right.
Okay. Okay, if I use an oxygen, okay, I go over there to my table and I'm in the group 6. So it has 6 valence electrons, which means it has 2 openings. Then you have hydrogen that comes in. It's in group 1, has 1. Another one, because it's 2 H's, has 1, okay? Now, here's the valence electron cloud for hydrogen, full with 2. Valence electron cloud with hydrogen, full with 2. Valence electron cloud of oxygen, full with 8. Now, because their orbitals, their electron valence shells overlap, they're sharing. Okay, so copy that down for the example. I'll get a little bit closer. Here's your definition for covalent, and then make sure you're drawing water. So you have oxygen with its 6 valence electrons, hydrogen with its 1, and then the 1 valence electrons from the hydrogen fill in the square boxes that had open electron spaces. Okay. You may pause, but we're going to move on. Next one, ionic bonding. Okay. Ionic makes ions. You're like, I still don't know what an ion is. Think of I, me, I want. They take, okay? Co-shares, I take. So ionic is when electrons are taken. So I takes electrons. So the definition is bonding between 2 atoms where one atom takes a VE. What do you think that stands for? Valence electron from the other. Remember, you can't take electrons that are in inner shells. You can only take electrons from the valence electron shell. So this is the definition I want you to put for ionic bonding. And our example is going to be this right here, Na and Cl, which is salt, sodium chloride. Okay, so here's where the taking comes from. When we look at sodium on the periodic table, it's in group 1. It has 1 valence electron. Chlorine has 7. Wow, it looks like it should be covalently bonded, but it's not. We'll find out the rules for covalently bonding in a minute or two, but this is what happens, okay? Sodium actually has 11 total electrons. 2, then 8, 2 plus 8 is 10, and then 11, 1 in its outer level, okay? Remember, the whole point of bonding is you want to fill your outer energy shell. So you always want to fill it to 8. So guys, can this sodium take 7 more electrons? No, that's so hard. So it would rather let somebody steal this last one, and then it would fall back to its previous inner shell, have a full inner shell of 8, and be happy. So when sodium bonds to chlorine, it actually lets chlorine steal that electron. Now, what is the charge for electrons? Electrons are what charge? Positive or negative? Negative, okay? So, tell me, one of y'all two girls, if sodium just lost a negative charge, if you lose a negative charge, do you become more negative or more positive? You just more positive. So that's why we say +1, because we lost one negative charge. If chlorine stole a negative electron, it becomes more negative. So that's why we say a -1 charge for it. Okay? So that is your example for ionic bonding, sodium chloride. So now we're going to talk about why things bond covalently or, do not need to be, okay, or ionically. Okay, so you're going to write this down where it says how, right here, how to tell if there will be an ionic or covalent bond. So all the next notes are going to go here. Okay, so ready? The electronegativity difference between two atoms influences the bonding type. You don't know really what electronegativity difference is, but it's just a property. Just like the property of density, just like the property of flammability, okay? Everything has an electronegativity property. So everybody has this number, okay? So the electronegativity difference between two atoms influences its bonding. When the difference is small or 0, the bonding is covalent. So think of it like this. When there's not much of a difference, so think about you and your friend group. Y'all are all kind of like very similar, have similar interests. So when you're not that different, you're good. You're covalently bonding. You're together, okay? Covalent, that's good. When there is a difference, when the difference is significant, the bonding is ionic. So when there is a great difference, are you going to be that person's friend when y'all are so different? No. Then you go to the extreme, which is ionic bonding. And going back here, we're sharing, yay. Ionic, me, mine, extreme, okay? So small difference or no difference. So remember, if you have a number, so say if the electronegativity of hydrogen is like 5.5. If H2 is your compound, H bonded to H, 5.2 minus 5.2, there's no difference. The difference is 0, okay? So metals are in generally low electronegativity. Non-metals are high electronegativity. So if a metal bonds to a metal, they have a similar, they're going to be covalent. When non-metals bond to non-metals, similar, they're going to be covalent. So ready, you have a metal plus a metal, similar, covalent. Non-metal plus non-metal, similar, covalent. Metal, which is low, plus a non-metal that's high, extreme different, significant, ionic. Okay, so let me give you some numbers, for example. And I'm just going to give you I'm going to make up numbers just to show you the difference. So say if we have a metal that is 5.2 and another metal which is 6.2, and the difference is only 1. That's similar. That is not a great difference, so they're going to be covalent, okay? Non-metal, we'll say 85 plus, we'll say 87.2. That difference is 2.2. Not that different, okay? Yes, they're so different from each other, but when they're bonded together, their differences are not that bad. Well, now, say if we take that low one, 5.2, and add it to that high one, 85, wow, that difference is 79.8. That's great. When there's a huge difference, that's when we know it's ionic bonding. So when we go back to our example of sodium chloride, if we would look up their electronegativity numbers, they would have very different electronegativity numbers, and that's why they ionically bond. Also, if you go back to the shells, that's why they also ionically bond, because sodium doesn't mind giving up that one valence electron. That way it could fall back to its outermost shell. Okay, so now going to the periodic table. Okay, so here's what you see. Actually, I'm gonna pull up Mia's from up here. Okay, let me set this up over here. Okay. We're going to explain this chart and we're going to have a quiz on it next class. If you have any questions, you have to email me or come see me. Okay. Now, Mia wrote a little bit of these, but we're going to go over it. So ready? Okay. Normally, here are the groups. The group, oops, sorry. Make sure that's still. Okay. The group is, so the group numbers, this is a 1, this is a 2, this is a 3, this is a 4, this is a 5, 6, 7, 8. Okay. This tells us how many valence electrons there are. Okay. So, this whole group with one valence electron, no, this is only for ionic bonding. Okay. Now remember, you got metals, and then you got non-metals. So your ionic bonding is mostly going to be between a metal and a non-metal, okay? NaCl, okay? So when ionically bonded, anything from group number 1, it has one valence electron, okay? So whenever you are bonding, remember, your last valence orbital, you either want a full orbital of 8 or you want 0, okay? Because when you have 0, you just fall to the previous full shell. So, for example, if you have 0, whatever this previous full shell is, that's what you fall back to. So we want either 0 or 8. Okay, so group 1. If you have a valence electron number of 1, is it easier to lose 1 to get to 0 or gain 7 to get to 8? Lose 1. So when you lose 1, do you become more positive or negative? You're going to lose an electron.
More
Positive. So that's why everybody from this group has a positive 1 denomination when ionically bonded. Okay, let's move on to the next one. 2, if you have 2 valence electrons, is it easier to lose 2 to get to 0 or gain 6 to get to 8? Lose 2 and get to 0. So when you lose 2 electrons, you become positive 2. So all these guys are positive 2. Good. We're going to keep on going. Okay, let's go to 3. Okay? Is it easier to lose 3 or gain 5? Lose 3. You get rid of those 3 negatives, you become positive 3. Good. Okay, here we go. This is going to become tricky. 4. And remember, here's carbon. Carbon is the backbone of life. Carbon is why we call things organic. It bonds everything together. Why do you think there's nothing over the 4? It's just as easy to lose 4 or gain 4. So I mean, I say it could go both ways, but carbon for the most part likes to be covalently bonded, and it likes to just be that middleman between everything. So on your quiz tomorrow, when I ask you, why does group 4 not have anything, you could say it's just as easy to lose 4 to gain 4, or you could say it likes to be covalently bonded instead. Okay, next one. Yeah. 5. Does it want to lose 5 or gain 3? Gain 3. When you gain 3 negative electrons, you become -3. Okay? 6. Do you want to lose 6 or gain 2? Gain 2. So this group mostly has -2s. Okay, when you're almost done. 7. Do we want to lose 7 or gain 1? Gain 1. That's why most of these guys are all +1. Okay, if we have a full 8, do we want to do anything?
No.
No. So this one over here, usually has nothing above it because it's happy. It's inert. Okay? So your quiz tomorrow, it's going to be this exact chart here. And what I did was I put letters above all these columns. So I said, here's A, B, C, D, E, F, G, H. Okay. And then I said, okay, in all of these, give me an answer. Why does column A always have the +1? Why does B always have +2? Do you think you could answer me that tomorrow? And it's all based on how many valence electrons there are. You'll be in this classroom, you'll be able to look at that chart there. If you're not in this classroom, then you'll have a chart for you. Okay, so that's your quiz. So you guys, that is your quiz tomorrow. But before I would do anything, finish this note sheet, okay, and then watch the first video on my Google Classroom.